So we're going to start out today. We're going to find determinant of, we'll just go with a 2 by 2 matrix to start with. Maybe.
So what exactly are those?
Alright. Each square matrix has this number associated with it called a determinant. One of the ways to find an inverse is by, or to find out if it has an inverse, is by using the determinant. So we're going to start, and you're going to love it because it's really easy. So it's going to be awesome, okay? To find the value of the determinant, somebody wrote this somewhere, by the way. It gives a lot of paper. If you have a matrix, and it's got to be a square matrix, okay? It has to be a square matrix. Now, these little bars right here, the bars don't mean absolute value. The vertical bars mean that I'm finding the determinant, okay? So if you see a matrix in bars, that's like an operation. That's like them telling you, find the determinant of this, okay? So, we cross AD minus C. That's your determinant. Okay. Super easy, really easy thing to do. There are a couple ways to do a 3 by 3, but we're going to start on just 2 by 2. Alright. These are really bad examples. I don't even remember these bad examples. Alright, so I have a square matrix. I want to find the determinant. Okay. So I'm going to multiply. 5 times negative 3 minus 2 times 6, which is a negative 21.
2 times 3.
Oh, 2 times 3. I was doing it in my head as I was saying it. 2 times 3 is 6. Sorry about that. Okay. So that's your determinant, okay? Now, how does that turn into an inverse? Well, then to find the inverse, we put 1 over the determinant, and we multiply it where those were A, B, C, D. D and A change places, and B and C change signs. And that's your inverse. Okay? So you find the determinant, and then you switch it around. So this one's inverse would be 21 times negative 3, 5. And then then you would use scalar multiplication to multiply that out, and that would be the inverse of the matrix. It's really not hard, okay? You're multiplying, subtracting, and then rearranging some stuff on a 2 by 2. That's what you're doing. Multiply, subtract, rearrange stuff. That's what you have to do. Now, let me ask you this. Seeing this formula, are there some matrices that may not have an inverse? Which one?
Or like if you have like zeros.
Exactly. If your determinant is 0, can you divide by 0? Mm-mm. So if you end up with a determinant that's 0, then you've found a matrix that doesn't have an inverse. Because division by 0 is undefined. So as long as it has a determinant, you can put 1 over that number, rearrange them, and you found the inverse. Right? Yes? We good? Okay, let's try one. Let's see
So
if I can find other examples of it.
is that just like the formula of how you put D and A and all that stuff? Like what
Yeah.
I'm asking is
Let's write out the entire formula. Let's say we had A, B, C, D. So that's A. Okay? The inverse of A, that's the inverse of A, would be 1 over, remember it's AD minus BC times, are you telling me to wait? Oh, okay. Sorry, I thought you were calling. Alright, remember A and D switch places, and B and C just change signs. That's it, start to finish. That's what you have to do. Whatever is in these places, that's what you do to them. Okay? This is your determinant right here. You gotta start with that determinant. That's where you start. Find that determinant, and then you just put it 1 over it and rearrange this stuff. And you do need to follow through the scalar multiplication, which kind of makes it ugly. But we'll do one start to finish. Does everyone have this written down? This is the formula. This is it. Okay, some people said no. So I'll wait. Alright, you got it? Okay. So let's say we want the inverse of, I want the inverse of that. If this is A, find the inverse. Alright, so we're going to start with 1 over what?
3 times 2.
Right, 3 times 2, which is 6, minus 4 times 1. And then what's going to go in there? And 3. Okay, so now let's simplify it. What does this end up being? 1 over 2, so that's 1/2 times all of this, which is 1, negative 1/2, negative 2, and 3/2. That is your inverse right there. Okay. It's a process. It's probably going to take more paper than you want to give it, but it's not difficult, right? You have your formula. It's not difficult. This only works for 2 by 2s. 3 by 3s, there are actually 2 different ways to find, and one of them is called expansion by minors, and the other one is diagonal. We're not going to get there yet. And it's really funny because, like, if you use expansion by minors first, that's the only one you want to use. If I teach you expansion by minors first, that's it. You will not ever use diagonals. If I teach you diagonals first, you'll never use expansion by minors. It's so funny. Whatever you see first, you're like, that's the one. That's the one. I'm like, I've never used that. It's so confusing. And then like 7th graders could come in and I could flip it and they'd be like, oh, I'm never doing that one. That's crazy. Why would you want to do that? It's so funny. So anyway, all right. So easy stuff. Let me give you one to do, or to try to do on your own. Let me do this with your neighbor.
Like a determined, like the only way you can do is if it's a square. Like
They has to. These are only 2 by 2s. That's it. We're starting with 2 by 2s.
so that like what I'm saying is like you just have to find the determinant another way with those, or is it called something different?
There's not one.
Okay.
Yeah. All right. Where were we? 2, 4, negative 3, 1. Find the inverse. Find the inverse of this matrix. So my inverse would be 1 over what? 14. Okay. Times. Okay, which would then be what? 1/14, 7, 3/14, negative 1/7. How easy is that? Right. Now, here's something really cool, by the way. If you multiply a matrix times its inverse, take the time to multiply these together. Alright, multiply these two together, the original matrix and its inverse. Now, what happens if you multiply a number times 2? 8 times 1 8, or 12 times 1 3. What's
Yeah, I was going to ask you that too.
Oh, it's not. Sorry. I thought that was. There you go. What happens if you multiply a number times its inverse? They cancel out. What are you left with?
0.
Not 0. 1. 1. Okay. So multiply these two together and see what you're left with. Let's multiply this. 2 times 1/14 is 1/7 plus 6/7. And then that's going to be negative 4/7 plus 4/7. Then you're going to have a negative 3/14 plus 3/14. And a positive 6/7 plus 1/7. Yeah, those are really hard fractions. 1, 0, 0, 1. Awesome. The identity matrix.
Like, they're not all going to be 1.
Okay, see, here's the thing. When you multiply a number times its inverse, you get 1, which is the identity number. When you multiply a matrix times its inverse, you get the identity matrix. And if you don't, you've done something wrong. Either your inverse is wrong, or your multiplication is wrong. See, this is just multiply matrix, what we've done for a while now. And then you get this. It's a way to check your work. You can check your work. Multiply the matrix you were given times the inverse that you came up with, and you should get the identity matrix.
So was that
Every time. Every time. Just like every time you multiply a number times its inverse, you get 1. Like, you can't multiply a number times its inverse and not get 1. Every time you multiply a matrix times its inverse, you get the identity matrix. Every time. If you don't, you've done something wrong. Either your matrix identity or your inverse is wrong, or your multiplication right here is wrong. Every time. Okay, let me give you one more, and then I will let you work on your, you only got 4 to do for homework. Okay.
If I'm doing this. Thanks, y'all.
Okay, that's not right. 3264. Sorry, hang on. 3264. Don't sit together tomorrow. You four, separate. The determinant on this one is 0. You end up with 12 minus 12, which is 0.
So you can work.
So there is no inverse. No inverse exists for this matrix.
Can't divide
Say
by 0.
that
You
ain't
just can't divide by, there ain't none, right? Yeah, that's exactly right. You can't divide by 0. Okay,
Unless
so,
you Chuck Norris.
I guess so, yeah. He shows up in class, and we probably all have a lot to learn. Alright, so see this page? By the way, I tried to white out at the top. It didn't work very well. Someone actually wrote out the formula in the book, because, you know, these books are like 100 years old, except it was wrong. So I tried to white it out, because I would hate for you to be looking at it, and, like, for you to be looking